Section 9.3 Arcs and Angles. This section explores discovering the relationships between an inscribed angle of a circle and its intercepted arc. This sketch represents, we have an inscribed angle and an intercepted arc. Now, you can see as you move the intercepted arc that the arc angle, there we are, arc angle is 50, and the arc, half the arc angle is our inscribed angle. And no matter how you move it, the arc angle is always double the inscribed angle, and the inscribed angle is always 1/2 the arc angle. As we just noticed in the sketch, the inscribed angle, which is right here, is 1/2 the intercepted arc, which is right here. So we can say the measure of the inscribed angle equals 1/2 the intercepted arc. As you can see, we have the intercepted arc, which is right here, and the inscribed angle, which is right here. And the inscribed angle is 1/2 the arc angle. Now, if you move the inscribed angle around, you can see that neither the angle or the arc changes measure. What we just did leads us to our next conjecture. The inscribed angles that intercept the same arc are congruent. So we just moved the angle around and discovered that however we moved it, the arc angle remained the same and the inscribed angle remained the same. So we know that the inscribed angle that intercept the same arc are congruent. Here's a summary of these two ideas in one. The inscribed angle is 1/2 the intercepted arc. So here is an inscribed angle. Here is the intercepted arc. So if we know that intercepted arc is 80 degrees, that means our inscribed angle would be 40 degrees because the inscribed angle is 1/2 the intercepted arc. Now, here's another circle. Here's an inscribed angle, and here's the intercepted arc. So we'll call this angle 40 degrees. Now, if we have another inscribed angle that intercepts the exact same arc, it's also 40 degrees because they're both intercepting the same arc. And we know that inscribed angles that intercept the same arc are congruent. The last two conjectures that you did and the exploration that you did on Sketchpad lead very nicely to this one. Angles inscribed in a semicircle are right angles. This makes sense because we know that a semicircle, the arc of a semicircle is 180 degrees. So any inscribed angle that contains a semicircle has to be 90 degrees because 180 degrees divided by 2 is 90 degrees. In the sketch that you submitted to Haiku, you discovered that the opposite angles of a cyclic quadrilateral are supplementary. So let's talk about a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral that touches each vertex is on the circle, okay? So we'll call this X, we'll call this angle Y, this one Z, and this one W. The conjecture states that the opposite angles in a cyclic quadrilateral are supplementary. So Y plus W must be 180 degrees, and X plus Z must equal 180 degrees. The last conjecture that you explored in your explorations is the fact that parallel lines intercept congruent arcs on a circle. So here's our circle. If we have two parallel lines, these lines are parallel, then the arcs on the inside, okay, they intercept congruent arcs. So this arc right here is congruent to this arc right here. Let's now apply some of the ideas that we just learned. Find the missing angle or arc indicated. So we have an inscribed angle right here. and it intercepts this arc right here. So we know that 70 times 2 is 140 degrees because we know that the inscribed angle times 2 is the intercepted arc, or the intercepted arc divided by 2 is the inscribed angle. So now we know that circles all the way around a circle adds up to 360 degrees. So we have question mark plus 128 degrees plus 140 degrees equals 360 degrees. So when we do the math on this, we have question mark plus 268 degrees equals 360 degrees. Question mark ends up being 92 degrees. Over here, we have an inscribed angle right here. Okay, but we don't know what this arc is. However, we do know that we have a semicircle right here. Since we have a semicircle right here, and this chunk is 90, the remaining chunk must be 90 as well, because semicircles add up to 180 degrees. So here is our intercepted arc, and here's our inscribed angle. So 90 divided by 2 is 45 degrees. So this question mark right here is 45 degrees. Example 2, find x and y. Well, we know that we need two equations because we have two unknowns, x and y. What we notice is we have a cyclic quadrilateral, and the reason we know it's a cyclic quadrilateral is because the vertices of the quadrilateral are all on the circle. So we can create two equations from this information because we know the opposite angles in cyclic quadrilaterals are supplementary. So 23 plus 3x and 22y plus 5 equals 180. So 23 plus 3x plus 22y plus 5 equals 180 degrees. Now I'm going to simplify this before I do anything. So I have 3x plus 22y plus 28 equals 180 degrees. 3x plus 22y equals 152. Now my second equation comes from the other opposite angles. So 6x plus 20 plus 16y minus 4 equals 180 degrees. So we're going to simplify these. 6x plus 16y plus 16 equals 180 degrees. 6x plus 16y equals 164. Now that I have my two equations, I'm going to decide which method to use. It looks like the best method, the most efficient method with this information is to do some sort of linear combination, adding and subtracting. So I'm going to multiply my bottom equation by -2. So I have negative 6x minus 44y equals negative 304. When I line up this equation with 6x plus 16y equals 164, I end up with negative 28y equals negative 140, and y ends up being 5. Now I'm going to take this y equals 5 and I'm going to plug it back into probably the most efficient one. So probably that one. So I'm going to say 3x plus 22 times 5 equals 152. So I have 3x plus 110 equals 152. 3x equals 152 minus 110, which is 42, x equals 14. So x equals 14 and y equals 5. One helpful tip that I want to give you for inscribed angles is if you're really having trouble finding the intercepted arc, take 2 blank note cards and place the note cards on the sides of the inscribed angles. And by doing that, it will block out the rest of the circle and you can easily see the intercepted arc. I recommend that for anyone who's struggling to see intercepted arcs and the inscribed angles that they intercept.